Okay, let's talk about colonizing Mars. For decades, it was pure science fiction, right? But for SpaceX, this isn't a movie plot. It's a real-deal engineering plan. So in this explainer, we're going to break down that incredible vision and then get into the tough scientific reality. And you've got to understand, this isn't just about business for Elon Musk. It's a deeply personal philosophy. The goal isn't just to visit Mars. It's to build a backup for humanity, to ensure we're around for the long haul. That's the real fire behind every single rocket SpaceX builds.
But look, this is way more than just a philosophical dream. Right now, engineers are hunched over their desks running the numbers. The vision is incredible for sure, but the big question is, does the math actually add up? Let's dig in.
To really get the scale of this, you have to understand the ambition driving it all. Elon Musk isn't just talking about planting a flag. Nope, his stated goal is to create a permanent, self-sustaining civilization on a whole other world.
And these posters, which hang right there in SpaceX headquarters, they tell the whole story. You see Mars on the left, as it is today, cold and red. And on the right, this lush, terraformed, Earth-like future. It's a constant, powerful reminder of the absolutely audacious end goal, a second home for humanity.
So, that's the dream. Now it's time for a reality check. In May of 2024, a team of brilliant engineers from the German Aerospace Center, also known as DLR, published a scientific paper that puts this very dream under the microscope. Their goal was, well, pretty simple, but also incredibly profound. Take all the public data from SpaceX, apply standard, by-the-book engineering principles, and just see if the numbers for a crewed Mars mission actually work.
In this study, it digs into every single critical detail. We're talking the weight of the ship, the travel time, and maybe the most important piece of the puzzle, that radical plan to actually make rocket fuel on Mars for the trip home.
So after all that number crunching, their analysis pointed to three major hurdles. Three huge challenges that question whether the entire mission, as it's currently planned, can even work. Let's dive into the first one.
Okay, hurdle number one is a big one, and it's all about weight. In rocketry, your mass budget is everything. I mean, every single extra kilogram you add requires more fuel, which then adds more weight, and you get stuck in this vicious cycle that's really, really hard to break. And this is where we hit our first major discrepancy. The DLR study, after they calculated the weight of everything, life support, radiation shielding, the whole shebang, they estimated that Starship's empty mass is more than double what SpaceX has publicly stated. That is a huge difference.
Yeah, this extra 104 metric tons, that is not a small rounding error. It has these massive knock-on effects for the entire mission. It impacts everything, but especially the fuel budget and, crucially, how long it's going to take to Mars.
And, well, that extra weight leads us directly to the second hurdle, the travel time. It's simple physics, right? A heavier ship is a slower ship, which means it takes a lot longer to get from Earth to Mars.
So these charts you're looking at, they're called pork chop plots. They're essential for planning any interplanetary mission. They basically show the trade-off between how much energy you need and how long the trip will take. And when the DLR engineers plugged in their much heavier mass estimate, they found the journey to Mars would consistently take way longer than SpaceX is aiming for. And the paper is super direct about this. It concludes that those ambitious targets, like, say, a 90-day trip to Mars, they're just not achievable with the current design and the estimated weight. The journeys would be at least a full month longer, every single time.
But, just getting to Mars is only half the problem. The third hurdle is arguably the biggest one of all. How in the world do you get back? The entire return mission hinges on this wild idea of manufacturing rocket fuel on the surface of Mars.
This concept, it's called in situ resource utilization, or ISRU for short. It's an absolutely incredible idea, living off the land on another planet. But it means the entire trip home depends on a technology that has never, ever been deployed at this scale, anywhere. You'd have to build and operate a fully functional chemical plant on Mars.
And to pull that off, the study calculates that a massive industrial plant would have to be sent to Mars before any humans even show up. And the total mass for all that equipment? A staggering 328 metric tons. To put that in perspective, that's more than 3 times what a single Starship can carry.
So yeah, this isn't some little side project. We are literally talking about landing a 253 metric ton propellant factory on Mars, plus a 64-ton power plant, which would almost certainly have to be nuclear,
and then another 11 tons of rovers and robots just to haul everything around. It completely changes the game. What sounds like a simple refuel is actually a monumental off-world industrial project.
Okay, so we've got 3 huge hurdles, right? The ship's too heavy, the trip is too long, and making fuel on Mars is an enormous challenge. So, what's the final verdict from the study? Is the dream over?
Well, the verdict, based on their independent analysis, is pretty blunt. They say that as it stands, the plan just doesn't work. The ship is too heavy, the journey too long, and most critically, the math for a return flight simply doesn't add up.
But, and this is a really important but, the paper doesn't just throw its hands up and say it's impossible. It actually offers a path forward. It's less of a dead end and more of a detailed, data-driven roadmap that points out the exact technological gaps that we need to close.
So this tough scientific scrutiny, it actually provides a kind of roadmap. The authors suggest real, concrete steps. Start with uncrewed missions to test all this tech. Bring in more international partners to speed things up. Invent better, lighter life support systems. And hey, just leave those early cargo ships on Mars to become permanent buildings.
And that leaves us with this final thought, right? Is a study like this a dream killer? Or is this kind of rigorous, independent scientific pushback exactly what you need? Maybe, just maybe, it's the most critical ingredient to take a wild, fantastic vision and actually make it real.